Hello everyone, thank you for joining. Today we're going to solve a bit challenging integer equation. The question simply says, given that x and y are integers, so we have integers, find a solution. If there are any solutions, find these solutions to this equation, right? So why don't you pause the video and try it yourself first, then we could go over it together. Yeah, to solve equations we normally factorize, but when we have something slightly more complicated, it's good to expand first and see if we can do anything with it. So why don't we start expanding this? We have x squared y squared plus x squared plus y squared plus 1 plus 2x minus y, 1 minus xy is equal to 4 plus 4xy. So the idea here is that we bring this 4xy on the other side, but we write it as 2xy plus 2xy. In other words, we write x squared, y squared, so this term, and then we use minus 2xy, so one of that term, and then we use 1 here, yeah, and then notice we have plus x squared plus y squared, so that and that. And then we use the second 2xy from there, right? And then plus the rest of the equation, so 2x minus y, 1 minus xy is equal to 4. The reason we did that, if you look at these three terms here, and look at these three terms here, we can write it as xy minus 1 squared, isn't it? So that's the first three terms. We can write it like that. Plus, and then we have x minus y squared, this three terms, isn't it? That will give us x squared minus 2xy plus y squared. Then we have plus 2. Now, notice this is xy minus 1, and this is 1 minus xy. So we can swap that around by, instead of writing plus 2, we can write minus 2 here, x minus y, and then xy minus 1. Yeah, so you do that. That's equal to 4. Right. Now we are in a much better position, because if you look at it, now this is a squared, this is b squared, this is 2ab, isn't it? So in other words, we can write this as a minus b all squared. So a, which is xy minus 1, minus b, which is x minus y, all squared, isn't it? Right? That will give us the same answer. That's equal to 4. So that implies x, y, minus 1 minus x minus y, plus y, I apologize, is equal to plus minus 2, right? Okay, and again, if you notice, we can factorize this. We can factorize it as x plus 1 into y minus 1. That will give us the same thing, wouldn't it? So that would be minus x plus y, that's right, okay, is equal to plus minus 2. So, in other words, what we have is we have x plus 1, y minus 1 is equal to 2, or x plus 1, y minus 1 is equal to minus 2, yeah. Well, we know x and y are integers. That means x plus 1, y minus 1 must be an integer as well. So we must either have 1 times 2 or 2 times 1, minus 1 times minus 2, minus 2 times minus 1. So here we want minus 2. That means we can have 2 minus 1, minus 2, 1, 1 minus 2, minus 1, 2. Okay, so we have to consider all these possibilities. I'll consider this bit here, and I'll leave that to you. So let's do it. So the first set, we must have x plus 1 is equal to 1, y minus 1 is equal to 2. Okay, so from that x is 0, y is 3. So that's first set of solutions. And the second is 2, 1. That is, we have x plus 1 is equal to 2. Let me remove the brackets. And we have y minus 1 is equal to 1. And what do we have from here? X is 1, y is 2. The next set of solutions are we have x plus 1 is equal to minus 1. Y minus 1 is equal to minus 2. So we have x is equal to minus 2, or let me write it as a coordinate. X is equal to minus 2, and y is equal to minus 1. Yep. And lastly, we have x plus 1, y minus 1. So x plus 1 is equal to minus 2. That's minus 1. Using this last possibility, so x must be minus 3. And y must be 0. Okay, so if you apply the same reasoning, you will get values for x and y here, and then you could go back to the original equation. Now you will see that you can, this solution satisfy this equation. All right. Okay, well, I hope you enjoyed it. I hope you found it interesting. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.